Thank you for having us here. My name is Austin Jamison, and I am a meteorologist at the National Weather Service office here in Phoenix. I'm one of the forecasters, one of the operational guys. Um, Tom Frieders is our warning coordination meteorologist, and that basically he's our main liaison with all of our external partners, whether that be aviation, land management, emergency management, and so forth. And Sean Benedict is our aviation program manager, and he would be here presenting this, but he's working overnight shifts this week. So we work rotating shifts 24/7. So that's why he's not here. So let's get into some weather. All right, so we'll talk about weather service products and services and some changes there. We'll give a quick overview of the monsoon outlook, and we'll focus a little more on aviation weather in relation to monsoon, and some resources and tools for the aviation folks. All right, so just to give a quick overview, the weather service largely has a field structure, and so there's a field office structure. And I'm in one of them, the Phoenix office, but they're all over the country. They have each their own territories of responsibility. There are specialized weather service units at the ARTCs, the Air Route Traffic Control Centers. So we work most closely with that Albuquerque Center, ZAB, but Palmdale has part of our area as well. And then there's some specialized forecast centers in the country, like the National Hurricane Center. There's the Storm Prediction Center, which you may be familiar with severe thunderstorm watches and tornado watches and so forth. And there's the Aviation Weather Center, which is probably the most relevant for our discussion. And so they provide national level guidance to the field offices, but also directly to those end users like the pilots and the controllers and the airlines. So I mentioned the forecast areas at the local level. WFO stands for Warning and Forecast Office. So that's a local forecast office, and the green area there that's our office's territory responsibility. And you can see the TAF sites there on the red dots. And so at our level, the TAFs are kind of the bread and butter aviation forecast that we do. But we also do something known as the area forecast discussion. And there's actually multiple sections. If you were to go check out this forecast discussion, there's an aviation specific section, and there's some other sections for other interests as well. But if you're not familiar with that, recommend checking that out. We also do something called an airport weather warning, and that's more for ground operations, luggage and fueling, stuff like that. Other things that we do in regards to aviation, we collaborate with the CWSU very closely on the Phoenix TAF forecast. And then we collaborate directly with TRACON and Tower, especially during highly changing situations. When thunderstorms are present, we'll be on the phone with them, and most closely with the traffic management unit at the TRACON, since things tend to flow down from there. So, and then we're doing outreach. We're doing a presentation like today. Sean, I believe, attends the flight training work group meetings. We engage in drills at Sky Harbor, or exercises at Sky Harbor, and we give other talks elsewhere. So the TAFs, it's a 24-hour forecast of the detailed conditions, I think everyone's familiar with, and the amendments and the change groups. We try and gear those toward the flight categories, but in our part of the world where we're not dealing with, IFR conditions and so forth very often, a lot of those from groups that you'll see in the TAFs have to do with wind changes, and especially if it's a change that would prompt a change in the takeoff and landing configuration. That'll be a common change there that you'll see on a from group. And this happens to be an example from earlier this year in February that you see down there. The AFD, that area forecast discussion, we update that with every routine issuance of the TAF package. So, you know, the TAFs are issued routinely 4 times a day, every 6 hours. And then we will amend those more frequently as necessary. But the forecast discussion gets updated with those routine TAF package issuances. And it's a free-form narrative where we're trying to give some background information on why the forecast looks the way it does. And we can get into things that it's hard to convey in the TAF because the TAF is very regimented with the format and it doesn't allow you to kind of get into those uncertainties and alternate scenarios. That's where we try and address that in the forecast discussion. In the airport weather warning there, we issue for Phoenix, Deer Valley, and Gateway, and we're focusing on the 35 knots or better on the winds and/or observed lightning or anticipated lightning, and then the visibility getting down a quarter. So of course, those conditions are going to be covered in the TAF, but this is a product that's primarily geared for the ground operations. So changes in NWS products. So the severe thunderstorm warnings, that's something for everyone. It's not necessarily geared specific to aviation. But the change that we did last year was to try and parse out severity levels, if you will, of severe thunderstorms. The basic criteria there you see in the upper right is for hailstones that are inch in diameter or more, straight line winds that are 50 knots or more. But we've got kind of 3 categories now. There's the base, and there's considerable, where you have the increasing size of hailstones and/or wind speeds, and then the top level is called destructive. That's where we're talking straight line winds of 80 miles an hour or more, and the hailstones greater than 2.5. And with that destructive category, with that will go to your cell phones. Those alerts will go to your cell phones. So it's called the wireless emergency alert system. Another change we made is we had this thing called a significant weather advisory, and that was a way to convey situations that were sub-severe but pretty significant. But basically, it's just now called a special weather statement. And it's, in general, we're going to be getting rid of advisories in the coming years, probably after 2024, just trying to go to more direct statements. But the SPS is what we'll be using to convey situations, for instance, like winds of greater than 40 miles an hour, relating to the thunderstorms, and hail that's less than an inch in diameter, that kind of thing. Something that that we're producing now. We used to have on our web page that we called the threat matrix, and it was a table there that tried to give a general overview of hazards and intensity levels. And we still do that, but we call it the weather risk outlook. And what we're trying to do is convey the idea of intensity as well as likelihood. So the more intense something may be and the more likely it is to happen, then the worse the color level, in short. So it's a way to try and capture 2 dimensions there, the potential intensity, if you will, as well as the likelihood of occurrence. And you see on the right-hand side there an example taken right off of our webpage. We have a geographic breakdown. There's an eastern part of our forecast area and western part of our forecast area. And in this case, the tab is highlighted on the eastern area. And this is, you know, general public consumption, emergency managers, and anyone. So, and with the wind there that happens to be highlighted, that's going to be for some pretty noteworthy winds that at the aviation level would certainly be noteworthy, but for general public, it's not as serious a situation, so to speak. And there's a narrative down there at the bottom below the table that you can get a quick overview of what's going on. Okay, so the monsoon outlook. These long-range outlooks are produced by the Climate Prediction Center, which is part of the National Weather Service. And they try and identify these different categories. So, when you're talking about the future, there's always a range of possible outcomes. And so, especially as you get further out in time. And so they try and identify three possible outcomes, above normal, below normal, and near normal. They try and say, okay, what's the percentage likelihood of each one of those categories? And so on the right there, you see the pie charts. That kind of gives you a sense of what's happening here. And that happens to be for Phoenix. And the upper pie chart is for the temperature outlook. And then the bottom one is for the precipitation outlook. So looking at temperatures, you can see there's a significantly larger likelihood of above normal temperatures versus below normal, unfortunately. But then looking at the precipitation, and again, and this is for July, August, September. So it's this kind of 3-month monolithic forecast, if you will. You can see that there's only a slight, even though there's some green shading on the map, it's not saying, oh, the forecast is above normal. No, it's probabilistic. So you can see on the pie chart there that there's only a slight favoring of above normal precipitation. For the June through August period, it's a little bit better shading toward the above normal, but you can see any one of those three outcomes really is about equally possible. And that's because there aren't distinct signals in the data to be able to lean one way or the other, maybe just a little bit toward the above normal. And maybe as you get further toward Tucson and the Mexico border, that above normal percentage gets a little bit higher, but it's still probably going to be less than 40%. So there's always those range of possible outcomes. And when it's straight across 33%, basically it's anything goes. It's random. So bear that in mind. All right, so let's talk about some weather situations that have impacts on aviation. And we'll talk about turbulence here. There's a variety of different ways we can get turbulence. We'll look at wind shear there in the kind of top center. So LLWS, low level wind shear. And so wind shear, certainly from a meteorologist's perspective, has to do with the behavior of horizontal winds, horizontally moving winds. And when you have a change in direction and or speed with altitude, now you have wind shear. But there are particular criteria for us to mention or insert that in the TAF. It's a 30-knot vector difference within 2,000 feet of the surface. That's the beginning threshold for us to put that in the TAF. So that's something to bear in mind, where you can have conditions that would be meteorologically wind shear, but would be beneath that criteria. And then looking below that, the inversions, I think most people are familiar with the idea of inversions, where at night the ground is giving off the heat, and so it's chilling, and then you actually have a warm layer above that, and so that abrupt change can be a source of turbulence. And we also, in tying back to the wind shear, it's in our part of the world, it's the nighttime often where we see those wind shear conditions most often, apart from thunderstorm related stuff or cold front related stuff, where let's say there's an approaching weather system and the brunt of it's going to be going north, but it's enough to get winds aloft strengthening, but below the inversion, the low level winds and the surface winds aren't really responding to that. So that's a situation where you can get significant differences in the winds within in the low levels, and it can be pretty abrupt. Back in the upper, and looking at the upper right there, something that we're pretty familiar with here in the desert Southwest with our heat are the thermals. So the sun's energy largely passes right through the atmosphere, especially when it's clear and dry. Well over 80% of that energy is going right through the atmosphere, and it goes to the ground. And then the ground heats up, and it's the ground that's actually heating the air. So you get these bubbling upward currents of, excuse me, of rising air. And you can have uneven upward currents based on the land cover. More well-vegetated ground cover isn't going to respond as well. It's not going to heat up as quick as, say, more bare ground or artificial man-made surfaces. So you can have uneven thermals, and that can be a source of turbulence there. And the clouds there, the cumulus clouds there, are indicating where the tops of the thermals have reached. And that you may not have any clouds though at all. When the conditions are dry, really dry like they often are here, you may not have that indicator. Quite often you won't have that cloud indicator to give you a sense of how tall are the thermals. And then looking in the lower right there, you got the good old-fashioned cold front, where colder, more dense air is plowing into warmer, less dense air, and that's causing upward vertical movement of the air. And that's can be a pretty sharp source of turbulence. And last but not least, the crosswinds. And we try and be mindful of that in the TAFs, where there's crosswind. We try and remember what the orientation of the runways are, and bear in mind what kind of a crosswind direction is there, and when the winds are going to be reaching those crosswinds. So thunderstorms, that's as was mentioned earlier, that's a big factor here, big safety factor. Anywhere you go in the country, it's going to be a big factor, but especially here, when much of the time we don't have kind of routine lower ceilings and visibility just due to run-of-the-mill showers and whatnot. The thunderstorms are a big deal. In the diagram there, the weather schematic on the right, what you're seeing there is downdraft air coming out of the thunderstorm. There's precipitation there. It's very rapidly downward moving air current, and it gets near the surface and starts spreading out. And so the leading edge of that outward moving air is creating a front in and of itself, a gust front, we would call it. And you can see the airplane there, the path, the glide slope there. It's coming in, hits that front, it gets an upward lift, and then it gets into a zone where you have abrupt downward moving air, and then it gets to a point where it's now got very strong tailwind. So that's a pretty wild ride, I'm sure, and I think pretty much everyone would know to stay clear of that. However, you don't have to have thunderstorms, full-fledged thunderstorms, to get that kind of behavior of those downward moving air currents. You can get a weak thunderstorm, or even just a shower that's producing virga, where it's weak, and you're getting that evaporative cooling of the precipitation below the cloud base, and that evaporative cooling induces accelerations of the air, downward acceleration of the air. So a very otherwise benign looking situation can be pretty dicey with the virga. And when you have virga, warm conditions, it's going to be more apt to happen than it would be maybe in winter time, where the subcloud aren't as warm and the contrasts aren't as distinct. So the dust storms are, of course, a huge factor there. In that animation there on the left, that's radar, this radar reflectivity. And I think most people are familiar with looking at that radar and get a sense of the intensity. And the more intense looking reflectivity, that's because there are bigger droplets there, or bigger targets hitting the radar energy is bouncing off of. But something that you should note in this pattern, this is a loop. See the leading edge there? That's the gust front. And so you can see how far away that those gust fronts can get from the thunderstorm cloud. They can go very far. I mean, that was probably, by Wickenburg by the time it dissipated. And so with those gust fronts, the leading edge of that colder air, it can scour the ground and loft dust up in the air. And so you see the picture on the right there. That's an example. That's a very noteworthy example. Oops, I kind of jumped ahead of myself there. That's a noteworthy example of a dust storm, a haboob, same thing. There's kind of two different kinds of dust storms. There's the thunderstorm gust front haboob, and then there's more like the April, gust to 30 to 40 mile an hour for a prolonged period. You have a lot of lofted dust or even dense dust. So different ways you can get visibility restrictions with the dust, but this is an example, a noteworthy example of a gust front driven dust storm, and that dust is thousands of feet high. It was probably 8 to 10,000, maybe more. So that was a pretty noteworthy example. And it also will depend, the intensity of the dust or the likelihood of dust production will be influenced by where is that air rolling over. Is it rolling over wooded areas? Okay, then you're probably not going to have it. Or is it rolling over Pinal County? Now you've got a lot better chance of having a dust storm. All right, so something else that we have to deal with here are mountain waves. And on the left there, you're seeing a loop of what's known as satellite imagery. It's known as water vapor. It's a really neat channel to look at because it gives you a different view of things. You can see more details and see more of the fluid behavior of the air than some of the other channels like IR or visible. But see the ruffles there, the ruffles ridges, so to speak. There are the waves there. You can literally see the waves, and you're seeing them in the lee of the Southern California mountains, the San Diego mountains there. And of course, we have our own mountains here that can create waves as well. But that's a very visually distinct indicator of the waves. Then on the right there, we've got a conceptual diagram of what's happening. And quite often, you get the waves in relatively stable conditions where the air is forced upward because of the terrain obstacle, and then but there isn't enough instability for those air parcels to continue to rise, so they settle back down, trying to reach an equilibrium. And then you have this propagating wave that happens. And so hopefully there's just enough moisture to see those lenticular clouds, but those are giveaways that you've got mountain waves and some pretty serious low turbulence potential, but you may not have those clouds there. There may not be enough moisture for them to show up. So definitely something to be mindful of. And the stronger the winds are getting, the winds aloft, the more apt you are to see this. And that can be with an approaching system that hasn't quite gotten here yet. The winds are strengthening, but you don't have enough otherwise lift for that air to just kind of dissipate vertically. They kind of keep on going downstream. Density altitude, that's certainly a factor here with combination of warmth and ground levels that are already at pretty good elevations. Cold, dry air is going to have lower density altitude than warm air, of course. And warm and humid, that's going to give you your highest density altitudes. Turns out that all else being equal in terms of temperature and pressure, humid air is less dense than dry air. And you may think, oh, well, it's stuffy, it's muggy, it's heavier. No, actually, it's actually less dense. So that combination of warmth and humidity is going to give you your highest density altitudes. And Prescott is a one that comes to my mind where the ground level is already 5,000 ASL, and you add to that on a summer day, especially like June, they're regularly in the afternoon get in the 90s, well into the 90s, and then you've got when the monsoon kicks in, get the humidity there, so that's a spot that comes to my mind as being a high density altitude location. And of course, Flagstaff, we've got such high starting point anyway. And with higher density altitudes, less lift, and I'm sure folks have seen YouTube videos of mishaps where the density altitude was not properly accounted for, and they did not clear the trees or what have you. They just couldn't get to altitude. So, all right. So in the data collection that we do in the Weather Service offices, there are a number of them that do balloon soundings. And you see a little video there. Our office does soundings only during the summertime because it's a partnership with Salt River Project and they pay for it. Otherwise, it's Tucson and Flagstaff that are the every day of the year balloon sounding locations in Arizona. Ground-based weather stations. The picture there is an example of an ASOS, automated surface observing system. We've got satellite data. We've got radar data. And all of these things are very important information sources for aviation. So the balloon soundings. What we're seeing there on that chart on the right, that's known as a Skew T log P diagram. And it's a way of plotting out the balloon data. And the balloon data is really pretty simple in what it's collecting. It's collecting temperature, humidity, pressure, and then it's inferring winds by the displacement. There's a GPS transmitter on them, and it's tracking that displacement and inferring the winds that way. And there's a lot of information here on the chart, but that red line that you see there, that's temperature. And then the green line is dew point. And so one item in this of interest in this case, you can see a little lofted, what I would call an elevated inversion layer. But there's a lot of information here. The closer together those lines are, the more humid it is, the more potential for clouds. And on the far right there, you've got wind barbs at the different altitudes. And those wind barbs, those are showing you the horizontal winds. It's not showing you vertical movement. It's just the horizontal winds. And on the left side there, those numbers, that's a vertical coordinate, but it's in pressure, it's in millibars. There are some indicators there in red of altitude in kilometers. So it's definitely a kind of a meteorologist perspective on the atmosphere. And there's a wealth of information there. That I could go on and on about. But there's some background if you want to delve deeper into interpretation there. The Storm Prediction Center's website has this data, these charts, plus explanatory information. Surface observations. This is a page right off of our website. And each of those forecast offices I showed you the map of, we all have our own website. So weather.gov/Phoenix, weather.gov/Tucson, Flagstaff, Las Vegas, so on and so forth. And from those websites, there's a little tab that says current conditions. And that's how you could call up the surface obs. And we're basically trying to pull everything we can. METARs, from everything from METARs to home weather stations that are getting put on the web and feeding into a system we have. So basically everything that's out there that we can get our hands on, we're trying to plot. And you can click on one of those station points and then get a table of data. And then even see graphs and so on and so forth. So, and also from that page, you can see where we've got, different kinds of hazard advisories and warnings and so forth. Satellites, for us, the bread and butter satellites are the GOES, the geostationary satellites, where that satellite itself stays in sync with the orbit of the Earth. So we're always getting the same view of the Earth. And there are two main ones for us. There's goes east and it goes west. So we're getting coverage from the Pacific across the Atlantic. And we get rapid updates. And there's a new generation of those satellites that have been recently launched in the last several years, where we have a lot better resolution. We have a lot better, more frequent updates. So really good stuff there. And you can look at this data on the web. There's different sources there. If you were to Google GOES, GOES, satellite data, you'd probably find one of these sites there. Radar. And as folks probably know, it's the acronym is radio detection and ranging. We've got 3 different options on our web pages that you can look at. There's the radar by radar page. By that I mean where you're looking at one particular radar's data at a time, and you can move over to the adjacent radar. So for us, the 2 radars that we control and operate, one is at Gateway Airport, and then that data feeds into our office in Tempe, and we control it from there. And then there's another one in Yuma. It's actually south of Yuma, near the town of San Luis. And then the Tucson office has one that they control in Flagstaff. The Flagstaff radar is southeast of Flagstaff on top of the rim. And from that page, you can get a whole bunch of different data that the radars are producing. There's a low bandwidth option you can access from there. And then there's also something called the MRMS. And that's radar data as well, but it's an automatic mosaicing of multiple radars. And there's a whole bunch of different parameters you can look at, and these extra algorithms that are applied to be able to see different types of data. And that's probably a little bit handier. It tends the responsiveness is probably better than that first one I was talking about, admittedly. But the data, because of that extra back-end processing, the timeliness is a little bit delayed. Oh, speaking of timeliness, if you've noticed the timestamp on the radar volume scan, that's from the beginning of the volume scan, not the end of the volume scan. So it always looks like the data is old, but really it's because that timestamp has to do with the beginning of the volume scan. And in storm mode, it's going to take 4 or 5 minutes to complete a full volume scan. And then in clear air mode, it's going to be 10 minutes. Okay, so some other useful websites that you're probably already familiar with and definitely should dive into is the Aviation Weather Center. That's our national aviation-centric information center and forecast center. So they're the ones that are putting out the AirMets and the SIGMETs. And they've got a lot of great information there. The TAF board, where you can see TAFs broken up by the hour by hour, the conditions in a table format. The GFA, the graphical forecast for aviation, there are tabs there that map out, ceilings and visibility and winds and turbulence, and it's a really handy way of getting a big picture view of things. And then the AFD, that map there's a way for you to drill down to the local office's area forecast discussion. And then you can find the aviation section and read that. There's a beta site, a beta version of the Aviation Weather Center's website. Where you'll have an interactive map display. It'll be mobile friendly, and that they're going to be transitioning to that in the fall. And then an addition that you've got on that page with the TAF board is the low-level wind shear is also now going to be available on that beta site. And the center weather service units, the ones that are the weather, those are weather service offices located at the artsies. They have their own websites as well, and valuable information there. And those center weather service units kind of fill in the gaps from what the National Aviation Weather Center is doing. As I recall, for those AirMets and SIGMETs, I think it's a 3,000 square mile area or bigger that they deal with. And then for conditions that are smaller in geographic coverage, the center weather service units pick up, and they'll issue center weather advisories and meteorological impact statements. They one of the things that's available on their website is a video. It's a short little video where it's they call it a pre-duty weather briefing, and so it's geared for the controllers there at the center, but it's also for TRACON folks, and just anybody can view that video and get an overview of what the weather's doing regionally. And then I mentioned the Storm Prediction Center. Their kind of classic specialty is helping provide guidance on severe thunderstorm watches and tornado watches. So kind of all things thunderstorm is being presented there. And they even are into what we call fire weather for land management agencies. But that's giving you nice handy plots of, okay, where is the thunderstorm area? And then zoning in from there, where does it get worse and worse in terms of thunderstorm intensity and conditions? And there's if you want to geek out on the meteorology, they have an analysis page where you can look at conditions at the surface and different slices aloft, and the soundings are also available there. So just a wealth of information. Then there's a aviation program website where there's a lot of general information kind of things. There's the Pilot's Guide to Aviation Weather Services. There's these safety charts. And I'd have to double check, but the cloud chart should be on there as well. It may be on another page, but something else to be aware of if you want to learn more about meteorology is something called Jetstream. And it is basically these online tutorials the structured series of tutorials that are at your own pace. A lot of good information there. So and then I mentioned our web page. This is of some screen captures here. The infographic at the top half of the home page there, that we call that the weather story. And the more non-routine the situation, the more likely we are to have one or more of these infographics. And that's anyone and everyone can benefit from that. It's not necessarily aviation specific. And then below the infographic there, the weather story, you've got this map, this kind of very plain Jane looking map. That's a clickable map. You can click on that and get a point forecast, even in the middle of nowhere. You can get forecast out to 7 days. You can get these meteograms, which are line graphs of different parameters, meteorological parameters, and a whole bunch of other stuff from that clickable map. And anytime there's watches and warnings and advisories, that'll be plotted on that map as well. And then below the map is where you've got all these thumbnails. That's the picture on the right, all these different thumbnails. And so that's where you can access those radar specific pages in the upper left there of those thumbnails. You've got the 3 radar options. You've got the satellite data, and there's a bunch more. So, and one last thing, I'll make a plug. I'm the Skywarn program manager. We have a volunteer program where we train people from the general public to help us learn about ground truth information, stuff that the technology is not able to detect or confirm. And so we'll train them on hazards to be aware of, how to properly identify significant cloud types and discern real things from fake things, and then how to report that And that helps us with our picture of what's happening. And then that helps us with projecting forward what's going to happen. So we've got webinars. In fact, I did one last night. I've got one tonight. We've got several more. So if you're interested in being a storm spotter volunteer, then check that out. And so that's all I've got for the presentation. And thank you again for having us. And if there are any questions, I'm here.
Well done, Austin. Thank you so much for doing this.
Sure.
This is Jim. I've got a couple questions.
Okay.
Specifically about thunderstorms in the Phoenix area. We know that the storms tend to build in the mountains around the valley. And it seems like, in typical monsoon activity, the ones in the north will slide down to the south, and the ones over Tucson will have a tendency to slide up to the north. Is it accurate to say that that happens because of the elevation change? Like, are those thunderstorms literally rolling downhill out of the mountains, or is that not accurate to say?
No, what's happening is so you see the storms form over the mountains first because you don't have to have those air parcels rise as high in order to get to a condensation level. It doesn't take as much lift before you reach the condensation point, and then you can get the thunderstorms to bubble on their own due to buoyancy. So the downdraft air from those, that is running downhill, you could say, but the downdraft air from those that creates a gust front, and that gust fronts, those gust fronts are a new source of lift. So what you'll tend to see is a generational process where you'll have an initial storm produces downdraft outflow air that creates a gust front. Now a new storm pops off of that gust front, and they could be discontinuous. You could have parent, child, that one dissipates, and then this one produces a downdraft, new gust front, new child, and then so on and so forth. But you've got to have the moisture, instability, and lift all together in order for those new storms to happen. And a lot of times on the lower elevations, you're lacking, you don't have quite enough of one of those ingredients. But it's that generational process from the gust fronts that is the most common reason why you see that evolution of mountains to valley. So, but and a lot of people, we have social media channels that we communicate with the general public, and you definitely see a lot of complaining when we don't get storms on the valley floor because people want the rain, but you need more lift. At lower elevations, you need those parcels to be to rise higher in order to get to that same condensation level. So it's harder to get storms to happen over the valley floor in that regard. Conversely, if you've got a good pool of humid air there on the valley floor, that can be very explosive. You can have actually more powerful storms on the valley floor than over the mountains. So,
quick related question. It seems, and maybe it's just my imagination, but as those storms come towards Phoenix, they seem to either stop or go around the valley, around the city, more than when I was a kid. I mean, just in the last 20, 30 years, it seems like that's changed. I've heard some people say that it's like as the city's gotten larger and we've got more concrete and asphalt and air conditioners, there's almost like a bubble of heat that stops the storms from coming into the city. Is that accurate, or is that just another misnomer?
It's probably a little sketchy, although there is a school of thought that due to the added heat, the urban heat island, the humidities are a little lower, and so it's harder to reach the condensation point.
It almost seems like you'll see the storm coming right for the town, and then it'll just turn and go away from the town. It's like, what's that?
But you're also losing the orographic lift when you get to the valley floor. You don't have the terrain obstacles, not near as significant of terrain obstacles to get that lift to happen. Plus, then you've got to force those parcels higher, or they have to go vertically more just to reach there. But there is a school of thought that maybe with reduced humidity due to the extra heat, that's a factor. But I don't think it's really well established. And I think it has more to do with it's needing more lift, and I think there's mountain valley circulations happening such that there's some return flow and some subsidence that's happening over the valley, and that hinders lift as well. So I think it's stuff like that is probably the bigger factors.
Gotcha. And I'm sorry, everyone, just one more quick question. The balloons, do you guys recover the transceivers from those balloons? I assume you've got a if found, please call number on them or something, right?
Yeah, I think that's pretty much it. The regular soundings that are done across the country, and not every weather service office does them, they're bigger, but they also have these parachutes on them, and there's labeling on them. Ours, because it's through with this funding through Saltwater Project, they're a little different. They're smaller. I think there is a label on there for returning, but basically
you guys don't count on it. And once it goes, you're done with it.
Yeah, once in a great while, we'll have somebody find one,
Gotcha.
and we'll get a call, and they'll say, "Hey, I found this. What do I do with it?" I remember one time, somebody in North Scottsdale called us, and it landed on their house because the balloon is attached by this long string to the instrument package, the sawn, and it was draped kind of on his roof and kind of dangling off the edge of the house, and it was in way far northeast Scottsdale, and so turns out our office is inside of the Saltwater Project Administration Building. So I called somebody from Saltwater Project in their meteorology department, and they were able to arrange for a utility truck to go out there and get it off this guy's house. So.
Interesting. Well, thank you again. This is great information.
Sure.
Well, it looks like that's no more questions. The only chat, and he says our glider DP says you would pass the soaring portion of the commercial glider practical test based on your description of all those updrafts and everything. So he says you'd pass.
Great.
So thanks again for the presentation. Did you send me that PDF of this? You said I could send that out, correct? So all those links that were on there, they could click on those
Sean.
links.
I think Sean sent that to you.
Yes, he did. He did.
Oh, okay, good. I was going to say if you don't see it, then I'll try and do that.
Because I can send that out to these guys. So all those links that were on there, they could click on and stuff.
Yeah.
All right,
I believe so. The presentation is like 150 odd megabytes, so it's not portable.
And I think he gave it to me in PDF. And I think the links were still working when I checked. So
okay, good.
Sounds good. Well, thanks for getting other questions. We'll send them your way. But thanks for the presentation. It was very informative and helpful.
Great. I'm glad. And thanks again for having us. And I will stop sharing.